And if I can't prove that, I'll just might as well throw up my hands, say, I want every vaccine shot possible available. I want the Johnson & Johnson, I want the Pfizer, Moderna, I want a cocktail of every single cold flu shot that's ever been given. I want the dose of the dose of the dose. And if my body starts looking anything like this branch, well, the proof might be is safe and effective, and that's a great place to start. So a lot of the examples I was just mentioning were extremely lackluster, because I'm really tired because I've been eating junk food for 3 days, and I'm trying to work out like an Olympian because I watch them on TV. And the dual complexity comes where the information wasn't given properly, mainly the fine print reading. The backside then is considered, perhaps the full circumference of, so yeah, you would have to get up and walk around the bush to make the fair estimate. But in this stanza, it's not entirely correct because there's more pink on the backside, but nonetheless, I would say a majority of the flowers are still simplifying complexity. It's not, let's count all these petals and see how many are pink versus white. You can just look at it, and the $1 million question, how much of this is pink? I just say the top portion, less than a half. In psychology, they have all these tests that you look for, and it's like images, and this is what are on a lot of barns. And so essentially what I've been doing with these trees, when you're looking at them, the bark has this specific ascribed bark on it, and then you can tell from the texture upon it the assembly of the symmetry. Very much what you would be doing with a microscope, looking for those patterns, but you can see them just because of the identity granularity of which bark presents, of the complexity of the fungus, mainly its coloration and population, are just constructs that instead of looking on a microscope, you can do it just because they have those elements. Screens. And even more so when you're not confined to a small microscope and you're using an app out and about, that you can understand things that I know fungus is orchestrating telecommunication to each other, and probably not by a telephone either. So the telepathy of a fungi is done in silence. So judging if it were going to having the tree bark make a overcompensation and return to a tree without having any fungi on it can only be seen if you take a further view of the vicinity, mainly this tree over here. The fungus on this tree has been brought down further than the point on the other one because it has more fungus on the tree than the other one. And leading in further investigation that most trees in the vicinity have the majority of the fungus taking over, which only leads me to believe that is more likely that the first tree we're looking at will eventually become more and more like these trees that have the majority of fungus across the entire tree. Because fungus does communicate with each other, it'll probably then gain an advance based off its localized constituents. I mean, why would you be making things more complicated with inducing apps in the microscope? Well, maybe there's a far chance that you'll be able to see everything you can see on a microscope, but on a larger scale. That's why that I point out the leaf reminds me of a basket, is that not that they're similar, it's just that you can understand that would be talking earlier about a woven basket, and then we'd be looking at dot set fill method, the bulge as opposed to the vacancy. The vacancy of this specimen mirrors a basket and is going to clearly, you can look at this and understand that it's going to eat more and more into the center because the center is not yet dried. This spectacle is cool because the duck is really well cast molded, and then it's put behind black bars so that the conformity is well kept. And then the finger painting on it, of course, is the horse of a different color, or I mean a duck of a different, almost mirroring the image of the cloth as a program. Side angle. The majority, and you say don't beat them, join them, but look at what this is comparing, and there's so many of them that the whole thing is almost turning into just one of them. So this is troubling, but then when it comes to something like that, this is what it is. The first guy who found out bacteria was a guy who got a whole bunch of microscopes, and then he put them inside wood cabinets, and he had these things that were prefixed on them in order to understand what he was doing better. The things that he really liked, he put them inside like mounts that were gold, silver, and brass. Had over 300 of them. And this guy was the founder of the bacteria, and I bet you would know, happened in 1663. Now, this is so interesting because he knew that he wouldn't be able to express himself entirely or effectively, so he tried for his entire life to put up all these like microscopes that had these prefix points in them. These prefix points, they had substances in them, substances of, you know, his bodily fluid, cow crap. He also put fleas' eyes. He put cow's crystallized, the whale's eye, its vitreous section crystallized. And that's important because in comparing the smallness of a flea eye, he was comparing that to just a part of a whale's eye. And so the stark relation between the two must have been uncanny. A hog's tongue. Yeah, he was covering all the bases when it came to the founding bacterial constructs. The discoveries were monumental. You know, nowadays it's more so that people don't do that sort of thing. Whereas there's apps. Instead of having a wood cabinet with bunches of microscopes in them, you can go on a device and download an app because it has a program with the same structure in it. Not a material, but of the binary components mimic the same data. So for each microscope in the cabinet, you could have one app because it's a prefixed data. And this would be so that he wouldn't have to have everyone over to come look at his cabinets. Everyone having a device just would be able to get the app and see everything that he found. And that's probably a great way to go about understanding bacteria better with utmost certainty, so that you don't put deadly compounds in your body. So crystals are like lines because when they're dropped in any random assortment, and then you get a further view of them, you'll see that they actually coalesced in parallel perpendicularity, almost as if it were a barcode. You, however, are not a barcode.